Assumptions for one-way ANOVA, which is a parametric test, Kruskal-Wallis test, which is a non-parametric test, repeated measure ANOVA, which is a parametric test, and Friedman's test, which is a non-parametric test. Assumptions for one-way ANOVA, which is a parametric test, a test that is used when the data are normally distributed. So what is ANOVA or one-way ANOVA? One-way ANOVA is abbreviation for analysis of variance. The test is a parametric test, which is used when the data are parametric, when the data are normally distributed. The ANOVA is an extension of t-test. It is a statistical test that is used to determine if there are any statistical significant differences between the means of at least 3 or more groups. Those groups have to be unrelated, unmatched, unpaired, independent of each other. So the one-way ANOVA is a between subject or subjects design. It tests that the means of multiple groups are equal or unequal. To perform the test, hypotheses have to be generated. For the null hypothesis, it will state that the means of all groups are equal. The alternative hypothesis will state that at least one group mean is different from the others. So reject the null hypothesis if the p-value is less than 0.05. The p-value is used to determine whether to accept or reject the hypothesis, the null hypothesis. If the null hypothesis is rejected, then the post-hoc test have to be performed to identify which specific groups are different. So assumptions. What are assumptions? Assumptions are certain characteristics or conditions or criteria that must be met before performing any statistical test. The purpose is to generate a valid and reliable results. Every statistical test have a set of assumptions. Violation of these assumptions can lead to unreliable findings from the statistical test and can lead to incorrect conclusions. So what are the major assumptions that need to be satisfied or fulfilled before performing the ANOVA? One-way ANOVA is the independence. Observations in each group are independent of each other. Normality is another assumption. The data in each group should follow normal distribution. And the major assumption also is the homogeneity of the variances. In that the variance within each group should be equal. So all the groups should have equal variances. There are 8 main assumptions that have to be fulfilled, looked at, and satisfied before performing one-way ANOVA. The first assumption is that the dependent variable is continuous. So the dependent variable is measured at a continuous scale, whether it is an interval or ratio. An example is weight, height, temperature. So the dependent variable have to be numerical variable, measured at a numerical scale. The second assumption is that there should be at least 3 independent unpaired groups. So the independent variable consists of at least 3 categorical independent groups. The third assumptions for the one-way ANOVA is the independence of observation. There should be no relationship between the observation in each group or between the groups themselves. There should be unmatched or unpaired groups. Data from one group should not influence the data from another group. How do you check that? By random sampling and making sure that there is no repeated measures. The fourth assumption is that there is no significant outliers. Outliers are extreme high or low scores in a data set that deviate from the rest of the data. How to check the outliers? By plotting a box plot, by performing statistical tests such as Grubbs test. If the data have an outliers or outlier in it, then data could be transformed. And the way also to solve the issue with outlier is to use non-parametric tests. The fifth assumption is the normal distribution. The dependent variable has to follow a normal distribution within each group. How do we check for the normality of distribution for each group? By visually inspecting a histogram or QQ plot or box plots for the groups, or by performing a normality test such as Shapiro-Wilk test, Kolmogorov-Smirnov test, Anderson-Darling test, and other tests. The sixth assumption for one-way ANOVA that have to be met is the homogeneity of variances. Homogeneity of variances, which is the homoscedasticity, is that the variance of the dependent variable should be equal across all groups. How do we check that? By plotting a residual plot for consistency in spread across groups, by performing Levin's test for homogeneity of variances, or Bartlett's test. Violation of this assumption is critical. Then another test, which is Welch test, can be used for unequal variances, or a Brown and Forsythe test. The alternative is to use a non-parametric test, which is Kruskal-Wallis test, for 3 or more groups. The fifth assumption is the random sampling. The sample should be randomly selected from population to represent the population. The eighth assumption is the equal sample sizes, which is optional. So equal sample sizes across groups increases the robustness of ANOVA if the assumption for homogeneity of variances is violated. This is a table shows that the major assumptions that have to be fulfilled prior to performing the statistical test, which is one-way ANOVA. The assumptions are independence, normality, numerical variable, dependent variable, homogeneity of variances, no outliers, and random sampling with the check method for each. So if the assumptions are violated for the ANOVA, then transformation of the data can be done using the log or the square root, or an alternative non-parametric test such as the Kruskal-Wallis test can be used. Assumptions for Kruskal-Wallis test, or alternatively can be called the H test, which is a non-parametric test. The test is an equivalent of one-way ANOVA statistical test that will determine whether there is a difference between multiple groups, 3 or more groups. The H test can be also called one-way ANOVA on ranks, and it is a rank-based non-parametric statistical test. The test will determine whether there are statistical significant differences between the distribution of 3 or more independent groups. So to use this test, the data have to be sorted into 3 or more separate, unrelated, independent groups. The test will also compare the medians for each group. Since it is a non-parametric, then the mean will be used for comparison. The test is an extension of a Mann-Whitney U test. The Mann-Whitney U test is a statistical test that is non-parametric. However, it is only used when there are only 2 groups, not more than 2 groups. More than 2 groups, 3 groups or more, then the Kruskal-Wallis test is the one to use. This is a test that can be used when normality assumption is violated. When the one-way ANOVA can't be used because the data is not normally distributed, then the Kruskal-Wallis test is an alternative test when the data are non-parametric. The H test can't determine which specific group or groups of independent variable are statistically significantly different from each other. So it can't tell which 2 or 3 or 4 or more groups that are different. It will only determine whether there is a significant difference between multiple groups, but without specifying which groups are different. So it can determine that at least 2 groups were different using post-hoc test. To determine which groups or 2 groups are statistically different, then the post-hoc test can be used. The H test does not assume normality in the data, so it is suitable for the data that are non-parametric. The test, which is Kruskal-Wallis test, is less sensitive to outlier than the one-way ANOVA. Outliers are an extreme low or high values that deviate from the other scores in the data set. The H test is used for non-parametric test. It doesn't require normal distribution of the data. The data can be ordinal or continuous. Ordinal data is categorical data with order in it, such as a Likert scale, which is used in surveys and questionnaire. Continuous data that has numerical scale in it, but is not normally distributed in this case. So the H test can be performed in a data that are ordinal or continuous. The test can be performed when there are multiple groups, and it compare these groups that are unpaired, unmatched, independent of each others. So to perform the Kruskal-Wallis test, null hypothesis has to be generated, and that null hypothesis will state that all groups have the same distribution, which means that the medians across all groups are equals. The alternative hypothesis will state that at least one group differs. So there is a difference between those multiple groups. So if the p-value is less than 0.05, then reject the null hypothesis. So what are assumptions? Assumptions are certain conditions or criteria or features or characteristic that of the data or about the data that must be met before performing any statistical test to generate valid and reliable results. Every statistical test have a set of assumptions or conditions that have to be satisfied or met. Violation of those assumptions can lead to unreliable findings, which eventually will lead to incorrect conclusions. Assumptions for Kruskal-Wallis test in brief are: groups are independent, observations are independent, dependent variable is ordinal or continuous, independent variable consists of at least two levels, two or more, and samples are independent and random, and the distribution in each group have similar shapes. So there are 5 major assumptions that have to be fulfilled or met before performing Kruskal-Wallis test on a data. The first assumption is that the dependent variable can be ordinal or continuous. Dependent variable can be measured on an ordinal scale or at a continuous scale that is not nominal but it is numerical and it is not normally distributed. The continuous scale can be interval or ratio. The second assumption is that independent of observations, which means that there is no relationship between observation within each group or between groups. So data within each group are independent of one another, and groups are independent, not overlapping, not related, and different participant in each group. That is the meaning for independent observations. Each participant belongs to one group. Violation of this assumption, then use an alternative test, which is Friedman test. The third assumption for Kruskal-Wallis test is independent groups. So the independent variable should consist of 3 or more categorical, unmatched, unpaired, independent groups. Example is the profession, in which the data can be sorted into groups such as doctor, dentists, scientists, pharmacists, and so on. Ethnicity, in which there are white people, black people, Asian, and others. Groups are independent of one another. There should be no overlap or paired relationship between those groups, so they are unpaired groups. So Kruskal-Wallis test can be used for just 2 groups. However, the best choice for 2 groups is Mann-Whitney U test, which is an unparametric test that can be used when there are 2 groups. The fourth assumption is that there should be similar shapes of distributions. The test assumes that the distribution of the groups have a similar shape, similar spread, similar skewness, as the data are not normally distributed. So if the distributions have the same shape, perform Kruskal-Wallis test to compare the medians of groups. Violation of the shape assumption, then use an alternative test, which is Fligner-Killeen test, and use Post-hoc test. The fifth assumptions that have to be met for performing the test is sufficient sample size. So each group should ideally have sufficient sample size to allow for accurate ranking of the data. Each group should have at least 5 observations to ensure reliable results. If some assumptions are violated, then use bootstrapping. Assumptions for repeated measure ANOVA, which is a statistical test, a parametric test that is used when the data are parametric, when the data are normally distributed. So one way repeated measure ANOVA is a statistical method that can be used to find out whether there are significant differences between the means of several groups, 3 or more related groups. Those groups have to be dependent. One way repeated measure ANOVA is a repeated measure, which means that the same subject or the same participant are measured multiple times. The same participant are measured repeatedly under different condition or different time point. The same subject is subjected to different condition. So there is a within subject design, which is repeated measure, and between subject design. An example of repeated measure ANOVA or one-way repeated measure ANOVA is a study to assess the effectiveness of 3 different teaching styles on the student test marks. Here in this example, the same participant is subjected to 3 different teaching methods. Another example for a repeated measure ANOVA is examining the effectiveness of 3 different drugs on lowering cholesterol levels. Here, whether the subject or the animal are subjected to the 3 different drugs, but the same participant participate in each experiment. Before performing the test, a hypothesis has to be generated. The null hypothesis for the repeated measure ANOVA states that the means of the dependent variables are the same across all conditions. The alternative hypothesis will state that at least one condition mean differs from the others. So to accept or reject the null hypothesis, p-value will be determined and calculated, and if the p-value is less than 0.05, then reject the null hypothesis. Once the test is done, a post-hoc test can be done if the ANOVA output is significant. This test will try to identify which specific pairs of conditions differ by performing t-test. Assumptions. So what are assumptions? Assumptions are certain criteria or conditions or characteristics or features that must be met prior to performing any statistical test to generate valid and reliable result. Each statistical test have a set of assumptions. So what happens if these assumptions are violated? This will lead to unreliable findings from the statistical test and to incorrect conclusion. The most assumptions that have to be met prior to performing the repeated measure ANOVA test is the normality, the sphericity, homogeneity of variances, and the assumptions of no outliers. So there are 8 important assumptions have to be met before performing repeated measure ANOVA. The first assumption is that the dependent variable is continuous, which means that it is measured at a continuous level as a repeated measures, such as interval level, ratio level. The second assumption state that there should be at least 3 or more related groups. These groups are categorical groups or related groups. In related groups, the same subjects are present in the groups. The assumption number 3 states that there should be no significant outliers. So outliers are extreme high or low values that deviate from the rest of the data set. So outliers can have a negative effect on the repeated measure ANOVA when the sample size is small. The outliers can distort differences between the related groups, and it can reduce the accuracy of the results. To overcome outliers, data transformation is one of the options. The fourth assumption states that there should be a normal distribution of the data. So the distribution of the data in 2 or more related groups should be normally distributed. In another way, the dependent variable is normally distributed for each level of within subject factor. So the difference between each pairs of conditions should be normally distributed, and this can be tested by Shapiro-Wilk test. The fifth assumption states that homogeneity of variances, which means that different groups have equal variances. The variances of the dependent variable should be roughly the same across all groups or all levels of the independent variable. The sixth assumption is the sphericity. Sphericity means that the variances of the differences between all pairs of the conditions are equal. In another way, the correlation between measurement, repeated measures at different time points or conditions are equal across all pairs. This can be tested by the Mauchly's test for sphericity. So what is the difference between homogeneity and sphericity? Homogeneity of variance means that equal variances in each group or measurement, time point or condition. Sphericity is the relationship between pairs of repeated measures across the conditions are equal. Violation of homogeneity of variance, then another test can be performed, which is Welch's ANOVA. If sphericity is violated, then a correction can be used, such as Greenhouse-Geisser and Huynh-Feldt adjustment. The assumption is the independence of observations between subjects. So observation should be independent across different participants, i.e. each participant set of scores should be independent of other participant scores. And the final assumption is the equal sample size across conditions. So each participant should have a score for each level of within subject factor, which means there is no missing values across the repeated measures. For repeated measure ANOVA, violation of these assumptions, whether the sphericity or the normality, then an alternative non-parametric version of repeated measure ANOVA can be used, which is the Friedman's test, or a generalized linear mixed model can be used, or the data can be transformed. Assumptions for Friedman rank sum test, which is a non-parametric test that is used when the data are non-parametric, i.e. the data are not normally distributed. And the test is used also when the data are repeated measures, which means that the data are paired or matched groups or dependent groups. So the Friedman test is a non-parametric test that is used for data that are not normally distributed. This is an alternative to the repeated measure ANOVA, which is used when there are matched or paired groups or dependent groups, and when that data are normally distributed. The Friedman's test can be used when the data lacks normality, and the test of repeated measure ANOVA can't be used. The test also detects the differences between matched or related or dependent groups. So the groups have to be related, which means the same participant participate in each group. The test is based on using the median, and it ranks the data before performing the test. So it takes the data and put them into ranks and then perform the analysis on the data. An example of a repeated measure that can be used for the Friedman test is when we want to compare the efficacy of 3 different teaching methods on student performance, whether any of the 3 different teaching styles can enhance the student performance. Then the 3 different styles are the 3 different groups, but these groups are not different, they are related, as the same participant participate in each group, and the teaching style for each group is given a label. A second example is assessing the satisfaction of a group of people for 3 different surfaces. In this example, the participant participates in 3 different services, but those groups are related because the same participate in each group, but with different surfaces, to find out how satisfied is those people from these services, and which services differ from the other. This example can be used when the data are ordinal. And another example for the repeated measure data is analysis of repeated measures in medical experiment. It is very often that a drug want to be tested, and volunteers or participants are assigned to 3 or more groups, but these groups are related because the same participant participate in these groups, and testing whether the dose or the time of the dose can improve the efficacy of the drug. So there are multiple examples in a situation where this test can be used when the data are repeated measures, when the same participant exists in each group, but with different conditions tested for each group. To perform the Friedman's test, alternative and null hypothesis has to be generated and stated. The null hypothesis will state that the distributions of the groups are identical, which means the median ranks of groups or conditions are the same. The alternative hypothesis will state that at least one group differs in distribution, at least one group has different median ranks from the other. And then a p-value is calculated. If it is less than 0.05, then reject the null hypothesis and accept the alternative hypothesis, which indicates that there is a difference between the groups. So the things with the Friedman test is that it will try to determine if there is an overall difference or differences between the groups, for all the groups without specifying which group is different from the other. So a post hoc has to be done if the p-value is significant. The post hoc test will assess pairwise group to find out the groups that differs. Assumptions. So this drags us to the main topic of this presentation, which is assumptions. Assumptions are specific conditions or criteria or characteristics of that data that have to be met before performing any statistical test to produce a reliable results. So each statistical test have a set of assumptions that have to be met or fulfilled. Violations of these assumptions can lead to incorrect findings and can lead to unreliable, incorrect conclusions. Some of the assumptions that are important for the Friedman test is that the independent variable has at least 3 levels in it, or 3 groups. The data come from related groups or matched samples, i.e. it is repeated measures from the same subject, the same participant participate in the groups. The samples are randomly selected from population, and the dependent variable can be ordinal or can be continuous. An ordinal variable is a variable is categorical, but there is an order in the category, such as the 5 Likert scales that is commonly used for surveys and questionnaires. Or the data can be numerical scale, continuous, but lacks normality. So the sample should not need to be normally distributed. So this test is designed for data that are not normally distributed. There are 8 assumptions that have to be met before performing the Friedman test. The first assumption is that paired related groups, which means that the test is for repeated measures data. Data have to be from the same subject under different conditions. This subject has been subjected to different conditions or criteria. Or those individuals are in a groups, but these individuals have matched or paired samples. Each participant participate in each group. The second assumption is that the data are ordinal or continuous. The dependent variable should be measured at either an ordinal rank data or at a continuous numerical scale, and that can be interval or ratio. And if it is a continuous data, then this data should be non-parametrics, which means lacks normality, to use this test. The third assumption is that there should be at least 3 groups. So the independent variable should consist of 3 or more related or matched groups, i.e. repeated measurements, which means that the samples are matched. The fourth assumption is the independence within groups, which means that the observation within each group should be independent of each other. No influence or overlap between the measurement in different groups. The fifth assumption is that comparable measurement scales, which means that the dependent variable measured on the same scales across all groups. The sixth assumption is rankable data. The data can be ranked, which means that order does exist in the observations. The seventh assumption is that there is no distribution assumption, which means that the test doesn't require that the dependent variable have to follow specific distribution. So this test is robust for violation of normality, and it is used when the data are not normally distributed. And the eighth assumption is sample size, as the sample should be sufficiently large to perform this test. So what to do when the violation of the assumptions is being detected or observed? Then use non-parametric methods such as Wilcoxon Signed-Rank Test for two paired groups. This test is used for two groups, and these groups are related. Friedman's is used for paired groups, but for three or more groups. Or alternatively, use the Kruskal-Wallis test when the groups are independent. If you find this video useful, do subscribe to the channel, leave any comment in the indicated box, and activate the notification bell to receive the recent and latest release into the channel of several different video clips, and click on the like icon and share the video link with others so the channel can expand and improve to include a large scope of different statistical method and how to analyze data using several different statistical packages such as SPSS, Excel, Stata, Jamovi, R-Statistic, or Statistics, GraphPad, Prism, G-Power, Python, and Mann. If you are a student or a researcher and you have a data, whether it is quantitative or qualitative, and you want to perform statistical analysis on that data using any of the softwares listed here, whether it's SPSS, Excel, Stata, Jamovi, R-Statistics, GraphPad, Prism, Mann, GMP, Python, then do contact me to arrange for either a one-to-one private tutor session or a training course on any of these statistical packages. My contact details are given here, so don't hesitate to write to me or email me if you need a private one-to-one tutoring or a training course.